10 surprising facts about black holes. 1. The first assumption about the existence of black holes was made by John Michell. Most people believe that the discovery of the existence of black holes is due to Albert Einstein. However, Einstein finished his theory by 1916, while John Michell had been thinking about the idea as far back as 1783. It had no use because this English priest simply did not know what to do with it. Michell began to develop the theory of black holes when he accepted Newton's idea that light consists of small material particles called photons. He pondered the motion of these light particles and concluded that it depended on the gravitational field of the star they were leaving. He tried to understand what would happen to these particles if the gravitational field was too large for light to leave. Michell is also the founder of modern seismology. He suggested that earthquakes propagate in the earth like waves. 2. They actually attract space around them. Try to imagine space as a rubber sheet. Imagine that the planets are balls that press on this sheet. It deforms and no longer has straight lines. This creates a gravitational field and explains why the planets move around the stars. If the mass of the object increases, the deformation of space can become even greater. These additional disturbances increase the gravitational force and accelerate orbital motion, causing satellites to move around objects faster and faster. For example, Mercury moves around the Sun at 48 kilometers per second, while the orbital velocity of stars near the black hole in the center of our galaxy reaches 4,800 kilometers per second. If the gravitational force is strong enough, the satellite collides with a larger object. 3. Not all black holes are the same. We usually think that all black holes are essentially the same. However, astronomers have recently discovered that they can be divided into several varieties. There are rotating black holes with an electric charge, and black holes that include features of the first two. Ordinary black holes are created by the absorption of matter, and a rotating black hole is formed by the merger of two such holes. These black holes consume much more energy due to the increased perturbation of space. A charged rotating black hole acts as a particle gas pedal. The black hole, named GRS 1915+105, is about 35,000 light-years from Earth. It is spinning at 950 revolutions per second. 4. Their density is incredibly high. Black holes need to be excessively massive at an incredibly small size to create a large enough gravitational force to contain light. For example, if you make a black hole with a mass equal to the mass of the Earth, you get a ball with a diameter of only 9 millimeters. A black hole with a mass 4 million times the mass of the Sun can fit into the space between Mercury and the Sun. Black holes in the center of galaxies may have a mass 10 to 30 million times that of the Sun. Such a large mass in such a small space means that black holes have an incredibly high density, and the forces acting within them are also very strong. 5. They are quite noisy. Everything that surrounds a black hole is drawn into this abyss and accelerates at the same time. The event horizon, the boundary of the region of spacetime from which information cannot reach the observer because the speed of light is finite, note mixed-stuff, accelerates the particles almost to the speed of light. As matter crosses the center of the event horizon, a gurgling sound is produced. This sound is the conversion of motion energy into sound waves. In 2003, astronomers using the Chandra X-ray Space Observatory recorded sound waves coming from a supermassive black hole 250 million light-years away. 6. Nothing can escape their attraction. When something, it can be a planet, a star, a galaxy, a particle of light, passes close enough to a black hole, this object will inevitably be captured by its gravitational field. If something else affecting the object, say a rocket, is stronger than the black hole's gravitational force, it will be able to avoid being absorbed. Until, of course, it reaches the event horizon. A point after which it is no longer possible to leave the black hole. In order to leave the event horizon, one must reach a speed greater than the speed of light, and that is impossible. This is the dark side of the black hole. If light can't leave it, we can never look inside. Scientists believe that even a small black hole will tear you apart long before you get past the event horizon. The closer you are to a planet, star, or black hole, the greater the gravitational pull. If you are flying toward the black hole with your feet forward, the gravitational force in your feet will be much greater than in your head. That's what will tear you apart. 7. They slow down time. Light skirts the event horizon, but eventually it is captured in nothingness when it penetrates inside. It is possible to describe what would happen to the clock if it were to fall inside a black hole and survive there. As they approach the event horizon, they will slow down and eventually stop completely. This freezing of time is due to gravitational time dilation, which is explained by Einstein's theory of relativity. The gravitational force in a black hole is so great that it can slow down time. From the point of view of the clock, all goes well. The clock will disappear from view, while the light from it will still be stretched out. The light will become more and more red, its wavelength will increase, and eventually it will go beyond the visible spectrum. 8. They are perfect producers of energy. Black holes suck up all the surrounding mass. Inside the black hole, it is all pressed so hard that the space between the individual elements of the atoms is compressed, resulting in subatomic particles that are able to escape. These particles are ejected from the black hole due to the magnetic field lines crossing the event horizon. The release of the particles creates energy in a fairly efficient way. Converting mass into energy in this way is 50 times more efficient than nuclear fusion. 9. They limit the number of stars. A famous astrophysicist, Carl Sagan, once said, "There are more stars in the universe than there are grains of sand on the beaches of the whole world." But it seems that there are only 1,022 stars in the universe. This number is determined by the number of black holes. The streams of particles released by black holes expand into bubbles that spread through the star-forming regions. Star-forming regions are regions of gas clouds that can cool and form stars. Particle streams heat up these gas clouds and prevent stars from forming. This means that there is a balanced relationship between the number of stars and black hole activity. A very large number of stars in a galaxy would make it too hot and explosive for life to develop, but too few stars are not conducive to life either. 10. We are made of the same material. Some researchers believe that black holes can help us create new elements because they break matter down into subatomic particles. These particles are involved in the formation of stars, which in turn leads to the creation of elements heavier than helium, such as iron and carbon, necessary for the formation of solid planets and life. These elements are part of everything that has mass, which means you and me.